All right, hi guys. All right, so I did the blue reactor, and I was looking at how they could use their plasma air purifying technology on the livestock industry. So the livestock industry is at a critical crossroad because people are realizing that it's having a bad effect on the environment. Also, because it's an important thing to know, the ammonia, 80% of global emissions of ammonia are coming from agriculture. And too much ammonia is just bad for the environment in certain ways. Like it's bad for biodiversity. Like certain plants won't grow with too much ammonia in the soil. And and there's this is kind of bad because ammonia is like a little high, and at the same time we see that the demand for food from animals is expected to double. It's coming up, and so governments have been taking this into account, and that now there's like a mission uh, the maximum acceptable emission rate being established in countries and being enforced. Like in the Netherlands, it's the government just like put in 172 million to help farmers be more innovative and to make their livestock housing more sustainable, specifically related to ammonia. And also, just another thing it's related to is in the livestock facilities, if it's bad quality air in there and like a lot of ammonia in the air too, and just like bad quality air, like the odors and like other particles like bacteria and dust or whatever, it's also just bad for the animal's health, and it's like lower quality of life for the animal, and it's also bad for workers who are in that environment. And there's also increasing concerns with animal welfare at the same time with concerns about the environment. So, we're kind of looking forward in the future here for a good solution, sustainable solution. All right. So right now, the current solution that's being implemented is they're scrubbing the air. They're scrubbing the air with these big filters that they use water and chemicals. You can have a biofilter or a chemical. You know what are they called right here? Let's just read. Yeah, here we go. They're acid scrubbers or bioscrubbers. So scrubbing part of the air inside the animal house, air quality in the animal environment can be improved, and emissions from the animal house of ammonia, odor, and particulate matter can be reduced. And so investment in operational costs of scrubber systems for livestock operations are considered pretty high. So people are looking to innovate and further develop new things for this problem of like keeping the air fresh and keeping it from and catching the ammonia and other bad gases and bacteria and everything. So, um, so with the current scrubbing systems that they have, it's like they are will be scrubbing the air. There's ones for like inside that takes in the air and captures like the ammonia with a certain method. Like the chemical one will be like splashing chemicals with water, like into the air, like washing the air, and it catches ammonia. And then they could use that and just be cycling that inside. And then they also have ones because you're trying to monitor your overall emissions of ammonia. So you have the building of the farmhouse, and then the ammonia is like leaving it, but you catch it with the acid scrubber before it leaves and goes outside into the environment. So you're not really putting it into the environment if you keep it all contained in the house. So that's just at the that one's just at the exhaust. They're called like exhaust scrubbers. So and here's the cost associated with this current solution that they have in the market right now. So the main elements determining the yearly cost of air scrubbing are the fixed costs and the energy use. And energy use is important because that's the main competitive advantage. Apparently, looks like the potential for the plasma systems. Like what the founder sent me, saying it's 90% more energy efficient than the current things that are out there to do this. And the fixed costs are have to do with energy use, and because there's continuously running spraying pumps, and also the acid scrubbers are using chemicals, which are an important cost factor as well. And the thing about the blue reactor systems is it gets rid of odors, bacteria, and harmful emissions like ammonia. It specifically can do ammonia, in the air without the use of chemicals, no biological agents, no water like constantly pumping, and or other materials. It doesn't filter or absorb the polluted air by like just catching like a big filter, like you'd picture like your laundry machine just catches it like a filter. It's like converting it at a molecular level because the ammonia goes in like NH3 and then it goes into the plasma and the plasma breaks it apart into individual particles or atoms and then you get like an N and three H's or two H's or I'm not sure, And this is one thing that I'm currently emailing the founder about because I'm wondering for an internal scrubbing system using plasma, at what rate would it be just taking in like ammonia and then just shooting it back out as the raw products of ammonia? What is the rate at which they settle in equilibrium of ammonia to the raw products of ammonia? So that's one thing I'm waiting for an email back. That looks kind of important. But, still looks promising, so we'll see. So the MVP, so we're going to have two, one for like the exhaust air and one for the indoor air cycling. The one that they're currently using are the air scrubbers. At the exhaust air, the most common end of pipe ammonia abatement technique is the application of an air scrubber system for the removal of ammonia from the exhaust air from the animal houses. So instead of using it there, we'll just put in the blue reactor air cleaning system instead. And for the indoor air cycling, we could also have it inside too. Okay, so we're going to look at and then we're going to talk about some specific competitive advantages that the blue reactor system has. So then looking at the value or the customer value proposition. All right, so we got the customer jobs over here, and these are actually, you know what? We should go here first. All right, so looking at the business model canvas. So our customer segments, we're just going after the livestock farmers, and we got some pig and we got some cattle just to start out as some good candidates here, and we're going to see more amassing into what more we can get other kind of livestock that would fit into this business model. So then we're looking at, for key partners, we're trying to see into the Ministry of Agriculture because we're specifically starting up in Holland here. So the Ministry of Agriculture, Nature and Food Quality, they're setting up these guidelines and putting out the money there to help people innovate and like think of new sustainable solutions to livestock housing. So, they look pretty interested in like moving to the future. Maybe people are always going to get more and more environmentally like thinking about the environment more and more, and people would become more radical. Ideas would be, even if they maybe cost more, which I'm still not sure about how the cost would compare, as still I'm trying to get more information. But if it's worth it, because here's the value proposition. It uses 90% less energy than traditional systems. Harmful gases, like ammonia, are removed, but also viruses, bacteria, and bad odors it's specifically good at getting bad odors as well. And it doesn't use carbon filters, water, or chemicals. There's no waste production. All materials are 100% recyclable. And so the key resources is the brand, the patented technology, in the case that they develop the right thing that would be applicable to the environmental solution. If they actually built a prototype for this, the patented technology of the prototype. And because right now they have filtration systems already that are in the market for like beer breweries to capture the odor there, and they're selling them, and they have it in the hotel industry to make hotel rooms smell better, and they're selling them there too already. So it looks like they have some technological like proof. All right. And then the team of expert installers, they are going to be the people, as we'll see here. They're going to be the people that go to the farmer's house, looks at his building, and then he himself will tell them, like, okay, yeah, we're gonna need one here, one over here, and like how to do it and put it all together. And it tells them about the environmental things about it, about how it works, maybe like some facts about like the technology itself, and that's the customer relationships right there. We're gonna maintain a relationship, dedicated customer relationships. Like each farmer is like we're gonna like show them a lot of good service, and installation team consultants are like tell them all about it, like really advise them about the best solution and be honest with them. And then so the channels, I'm thinking like sales rep can try to contact these farmers with the products, and then there'll be post-purchase customer support. All right. So yeah, the key activities, they'll be installing the systems into the farms. They'll be into livestock facilities. They'll be maintaining them, and they'll be doing research and development because it's such an innovative area that there's more and more applications that could be used. And yep, the costs are going to be the product production cost, and then the routine maintenance cost, and the research and development, and the revenue is just going to be the product sales. This year we got the farmers are trying to meet regulation standards, keep animals healthy, keep staff healthy. The pains are high energy costs, chemical costs, water costs, and the bad odor. And then the gain would be easy installation and maintenance. So then the pain relievers come in 90% less energy than traditional systems, and it doesn't use water, chemicals, and doesn't produce any waste. Good at odor removal, compliant with regulations. And so basically, this is like the last email I sent the founder, and he's been responding to me like every 2 days. He says he's very busy, but I asked him. So I'm saying, is the replacement of the current air scrubbing technology with plasma filters viable? Is the idea that plasma purifier could scrub internal air and of pipe exhaust or both? So I want to know, like, would the plasma reactor be able to circulate the air internally? Would that lower the ammonia concentration? At what level of chemical equilibrium do the raw products of ammonia and the compound ammonia settle within the livestock environment? So to know, like, what does it end up doing to the internal if it's constantly breathing in ammonia and shooting out the raw products? And is there an idea of using plasma to tackle the excesses of ammonia in another way, like during the process of manure storage, disposal, and treatment? And manure is like the source of ammonia. And so that's what I'm just waiting for this email back. But it's been pretty interesting talking to him, and I think he'll email me back pretty soon, and I can keep working on it and finish it up. But that's it. So see you guys later.